Okay, hi folks. So now we're going to do an example of a weak base calculation. So 15 molar solution of ammonia, okay? And we get the Kb value, 1.8 times 10 minus 5. So we're going to set this up like a rice table. This is going to go very similarly as our weak acid, but we're just going to have a few extra little details in getting the H plus from the OH minus. Okay, so we'll set up our rice table, RICE. Our reaction is ammonia, NH3. Okay, and ammonia, with this weak base reaction, we do need to include the water to get the reaction correct. And so we remember now that this is going to make NH4 plus OH minus. And it's that OH minus that we're interested in. Okay. So we'll set up our grid. And we also recognize here we don't care about water. We're not going to include water in our equilibrium expression. So just as a reminder, we know that that equilibrium expression is going to be Kb, which equals 1.8 times 10 minus 5. And that's equal to the ammonium concentration, NH4 plus, times OH minus, all divided by the ammonia concentration. Okay. So we were told that that's a gigantic 15 molar. So I'm expecting this is going to be very basic. So we'll assume that's 0 and 0 to begin with. We know then that that's going to be minus x, and this is plus x, and this is plus x. And now we've got 15.0 minus x, and then x, and then x. And once again, you can see the game that's played here. We've got a very small Kb value. We've got a very large initial concentration. So we can assume this 15.0 minus x is approximately just 15.0. All right. So now when I plug all of that into my equilibrium expression, 1.8 times 10 minus 5. Oops, that looks like it's to the 15. So let's write that again. To the minus 5 equals, and now that's, I'm just going to write it directly. X times x gives me x squared, all divided by 15.0. And so now we can see our math is going to be very straightforward. 15.0 times 1.8 times 10 minus 5, and all square root of that will equal my value of x. Okay, so now that's 1.8, 1.8 times 10 to the minus 5, and let's make sure that that's in there correctly. Yep. And now that's times 15.0 equals, and then square root. And here I get x to equal 1.6 with 2 sig figs because of the Kb value. So that's 1.6 times 10 to the minus 2 molar. Okay, so that means what's important here now, it's my hydroxide that I care about. So my hydroxide is 1.6 times 10 minus 2 molar. And I remember now that if I take the negative log of that value, that's going to give me the POH. Okay, so let's say log, and remember I multiply by the negative sign. So now if I know that my POH equals, that's going to be 1.78. Remember, 2 significant digits in the log, meaning 2 decimal places. I prefer the calculation where I subtract that number from 14 to make this easier. All right, and I'll write all of that out just to make sure that we're clear on that. pH plus POH equals 14.0, which means pH equals 14.0 minus POH. And I can trust from my last example that this is going to give me the right answer. And so now, let's see here. Because I've already got the negative sign right there, I'm just going to say plus 14. Yep, and it's 12 point, let's see, I guess that should be 12.22, right? with the way that I'm going to round. And also I can see if I were to add 1.78 that 1.78 to 12.22, that makes 14. Okay, great. So now the last thing, of course, we've got to do is check our 5% rule. And so that's going to be the value of x, 1.6 times 10 minus 2, divided by the initial concentration. And hopefully you can see that's definitely going to pass the 5% rule. But we'll do it just in case. So 1.6 times 10 minus 2 divided by 15. And you can see that's definitely less than 100%. And I'll multiply it by 100 just so we're clear. So that equals 0.1%. So that definitely passes the 5% rule. Okay, folks? So not all that different than making weak acid pH calculations. We just have to remember that when we're doing this for a weak base, what we're really going after is the hydroxide concentration. And we have to convert that hydroxide into a POH, which we can then convert into a pH. Okay.